it's the issue with my OS.
I am sharing it. Can you see it?
No, I am still not seeing it. Let me just check once.
Okay, maybe you should just look into your local and start it, and just tell me to change the slides, and I'll change.
Yeah, sure. I think we are in the sync right now.
Okay.
I'm seeing it. So, hello everyone. Let's just continue the presentation. So, first of all, I'm going to talk about DevOps, what DevOps actually is, and then we will be moving on to the dual factor app methodology. So, first of all, as we talk about DevOps, so DevOps is basically a set of principles and practices. So that basically combines all the software development and the IT operations. So before the DevOps was introduced, so the devs and ops part was basically two different parts, and they would not come between, and there was not a lot of collaborations. So DevOps is basically a practice that enables you to just for a more collaboration between the software development team and the operations team, which helps to deliver the software and services at much higher pace and without less bugs, and smoother release to the production with the infrastructure totally reliable and scalable and stable, so that nothing breaks in the production. So the DevOps part basically focuses on the automation side of the thing, the collaboration, and also the continuous improvement of the whole software development cycle. So basically, DevOps is not a one-time process. So DevOps is continuously improving the life cycle, the pipelines, or whatever it is in the DevOps pipeline, the software development life cycle, from the planning phase to the let's just say the development phase to the build phase to the release phase and final to the monitor phase. So after that, we will be moving on to what DevOps actually does in a software life cycle. So DevOps is basically included in every part of the software development life cycle, right? So you try to automate everything that is able to be automated to facilitate the teams of the software development, so that the processes can be faster and the release to the production can be good, and also the codes are very secure, and also the builds are very fast, and so everything that allows you to get from the developer machine to the production in the shortest amount of time, that is basically done through DevOps. So DevOps helps to facilitate all of them. So for this, different kinds of tools are being used on DevOps part, right? So we use so most of the automation tools like Jenkins and GitLab CI/CD and Circle CI. So they all are one most of the important tools, or let's just say the most popular tools that are used throughout the industry. So different teams have different perspective on different automation. So in the DevOps is all about the processes. So we go more through the processes and tools, that it's just about the teams that which you like to prefer it. So at the end, we like to do automation for everything. So the DevOps mostly consists of let's just say many types of topics under it. So the continuous integration, continuous delivery, continuous deployment practices. So they all fall under the DevOps, and also infrastructure as code, configuration management, and version control. So everything falls under the DevOps, right? Uh, so after that, we will be moving on to the DevOps and how it is connected to 12-factor app methodology. So DevOps is a principles, right? So when you connect DevOps to 12-factor app methodology, so 12-factor app methodology is basically a blueprint of how you should be developing a cloud native application. So which will have all the important aspects of what a stable or what a good cloud native application should look like, with all the capabilities to scale, to security, to let's just say collaboration and everything and all. So if we want to introduce what 12 factor app methodology is, so 12 factor app methodology is a set of best practices that allows us to build cloud native applications. And in the second point, DevOps and 12 factor app, so they basically help to implement both of them. So DevOps is a principle, and with the tools and DevOps, with the tools that are used in DevOps, that as I said before, like Jenkins and GitHub Actions, and GitHub, AWS, and the cloud providers, and IAC's tools like CloudFormation, Ansible, and Terraform. These all help to implement what a good 12 factor app methodology should be implemented, or how the app should be created. So yeah, as I said before, DevOps tools like Docker, Kubernetes, and Git, they all help in easy adaptation and implementation of the 12 factor methodology in the software development. So on the next point, so the 12 factor app methodology mainly contains 12 factors. So first of all is our code base. So what basically a code base is like, it's a distributed system, so that helps you to collaborate between the developers to connect on a single code base, so that they can all collaborate. So one of the best, or one of the most widely used um, version control system is Git. So I think people should have knowledge of that. So I'm talking about Git. So version control like Git, and also older version or older, let's just say it's a legacy version control system like SVN is also used in some kind of legacy systems. So else than that, everybody is committed on Git. And so a code base, so it is tracked in version controls, and which helps to enable multiple deploys. So for that, so this part of the code base, it helps to reduce the duplications and also allow for easy collaboration. And many Git hosting providers like GitHub, it helps to collaborate between the different, or let's just say multiple developers to work on a single project without affecting the timeline. And then other than that, so on the next part, we have dependencies. So dependencies is like we have an application. Let's just say we have an JS application. So its packages are stored in the package managers, right? So like npm, yarn. So we try to explicitly declare and isolate dependencies from other applications, right? So we do not try to rely on implicit dependencies. So we try to use a dependency tool. So Yarn, and let's just say in Java we have Maven, and in the Python we have a pip installer, and also in Ruby we have anything else. In Rust we have everything else. In Go we have all other than that. So let's just say we try to manage all the dependencies in one file, so that it can be used to install dependencies and all other stuff like that. So after that we have a configuration, right? So the configuration is stored in the, so what this config part says in the 12 factor app methodology is, so config should be stored in the environment and not in the code, right? So what it actually says is, if you do a real life software development, so most of the time on the, if we try to deal with it, then the all the the configurations are might be stored in the code itself, right? So using the constants or whatever you explicitly try to con- store configurations, like the database configurations, and we say the API keys, and let's just say some kind of third-party APIs and all the stuff like that. So through the 12-factor app methodology, and what I also believe is that so it should be stored in the environment. So the environment can be determined by env files, as we used basically in the Node.js projects. So you can just define an env file, you can just take the values from it, and you just try to use it from that, so that you can uh, run the code in different environments with different values, and so the values are not really dedicated inside the code, and it can be taken from the environment, right? So yeah, it just says to avoid hard coding configuration values in the applications, and try to use the environment variables for it, so that it can be used in different environments with different kinds of configurations. So on the next, we have the factor number 4. It's the backing services. So what backing services actually is, so in the code base we try to write all the logics, right? So the logics might be what what we say is, so the logics might be connected to all kinds of backing service. So in the microservices, the backing services can be some kind of database or the message queue like RabbitMQ, Postgres, or different kinds of databases that we can use. So that can be a backing service. So that should not be inbuilt inside the code itself. So you should try to run it as an attached service, so that once the code, so if we do not need a database this, so the database can be, different databases can be used exactly like that. So what we said before in the config file, we try to, so I will try to add it with the backing services. So we have some kind of MongoDB databases stored in the environment. Since the database is already a backing service, I should be able to change it accordingly, right? So for the prod, I can choose another database. For another staging environment, I can use another database. So I just get to change the variables inside the database, and I should be able to just connect it to the system and run it as I like it. So it also tells us to avoid vendor lock-in by using abstractions layer. So like AWS might be providing their kind of specific services. So we just try to not to stick into the same kind of services, and so that we can just use a different kind of services, some open source alternatives, right? So MongoDB, PostgreSQL, so yeah, that kind of services. So on the next part, we will be using, we have a build, release, and run. Right? So in this factor, so we basically talk about what CI/CD is in the DevOps part. So first of all, for the product, we try to build a reproducible builds and immutable releases. So that just means that you try to use the same build for the different kinds of stages, and it can be determined only by the configuration that are provided by the environment. So rather than hard coding everything for each step, and the build should be dynamic. If there is one build, then that can be run in the staging, also into the UAT and into the prod, only by switching the environment variables or the configuration related to it. So yeah, we just, and also it makes sense to strictly separate build, release, and run stages. So basically, the CI/CD should run in different stages, and what it's being run in the production state, they should be different. So if the CI/CD is done in the GitHub Actions and other than else, so the stages or the running stage, it will be done in the server itself. So yeah, the build tools like Gradle, Maven to create executable artifacts. So this is in the case of Java. So yeah, for the Node also we use Yarn to build some kind of stuff like that. And currently there's Docker too, right? So we can use Docker build to build the image that we want. So Docker is, it's not that it's really platform agnostic. So you can use any type of framework to build a Docker image. So yeah, we can use it. So for this, different kinds of CI/CD tools are also used. So Jenkins. So the build, release, and run process is done. So for the automation part, we do the CI and CI/CD part through the different kinds of tools that you have seen, that you're seeing in the slides, like Jenkins, and we have GitLab, and we also have a solution provided by GitHub Actions, Circle CI, Travis CI, and there's also Kubernetes-based platforms like Argo CD and Flux CD. So everything is done to it. But in the end, so platform is just about how you try to use it. You just need to shorten the process and you try to automate it so that it becomes easier for the developers to see the changes, and so that the feedback loop is very, very short, and we can bring more changes or fixes the bugs that are in very, very short time. So in the next slide, we have processes. So yeah, the process that I was saying before, once it is built, so it is run, right? So we need to run the process that we have already built the binary, or let's just say we have a Docker image. We have Docker image in the DevOps side. So we need to run the Docker image, right? So for Docker image to run as a process, we can just run it at a container. As in what you're seeing in the screen, it's running a PM2 process. So PM2 process manager is basically mainly used to run Node.js applications in production. So it also helps us to determine a process of Node.js. and it will run the Node.js process in the server so continuously without stopping it. So it is a very good tool that I also use in my organization to basically handle the Node.js applications to scale it if it's necessary. Let's just say to make it scalable and highly available in our organization. So yeah, so the process is mainly basically trying to execute the app as one or more stateless processes. So one is not connected to other, and let's just try to use process managers like PM2, or we can also, if you are in Linux servers, then it also we can also use Linux-based system managers like systemd to basically formulate a highly scalable uh, process managers to just application to run your application in very highly available way. So in the next part we have port binding. So port binding, it basically says to export services via port binding, right? So it says, as we all know, I think if you are already developing an application, we can say that a certain application is always binded to a port, right? So what it says is if we have a Node.js application, it might be binded to a certain port 3000 by default. So yeah, that should not be by default, it says. So it tries to export services via port binding, right? So if we also use a Docker, so we try to use Docker. So when in Docker, we try to export a certain port out of it, right? So that only that port is available in the outside network. So we try to use it to specific to, we try to avoid binding it to a certain kind of a certain port or a host name so that it cannot be binded to it. So let's just say I should be able to bind it to whatever port I needed. So port binding is, yeah, basically that. So after that, there's a factor of concurrency. So it's a factor rate in the 12 factor app methodology. So what concurrency basically says is, so any program once run is represented by one or more processes, right? So PHP processes also run as child processes. So Java processes also do same. So different have different kinds of processes, right? So for that, processes should be a first class citizen, it says. So basically, we use in the DevOps world, we try to use Kubernetes for it. So Kubernetes is a container orchestration tool that is used a lot in cloud native environment. There are also different kinds of tools coming in the market. Docker Swarm is also one of them. So, but also there's an called Nomad, I think, from yeah. There's also Nomad from HashiCorp. So there are a lot of tools. So it is also an open source. It is used to just orchestrate all the containers that are being deployed by the Docker. So it what basically does is to it tries to scale out the containers, right? So it helps to enable the horizontal application scaling. So vertical scaling is basically if we have a server and we try to increase the specifications of that single server, then it's called a vertical scaling. But it cannot be very efficient to while coming into handling a bigger application, so that it cannot be very highly available and it might go down at any time. So we can use a different kind of approach, a horizontal application scaling, so that you can just replicate multiple instances of it, and it so multiple instances of it, and it will be connected by some kind of load balancers, so that you can just distribute the traffic and everything is fine and your application does not go down. So yeah, concurrency is basically that you try to scale out by a process model, you try to enable horizontal application scaling, you try to just not do some kind of vertical scaling and try to leverage container orchestration tools like Kubernetes in the DevOps world, as we say in the DevOps world, to just make your application just scalable, highly available, and all the stuff like that. So on the next part, we have disposability. So for the disposability, if we try to give take this approach from our DevOps approach, then we try to make the application disposable, meaning that can be started and stopped at a moment's notice. So we try to facilitate the fast elastic scaling, rapid deployment of code or configuration changes, or just production deploys should be fast. And we try to maximize the robustness of the whole system. Let's just try to minimize the downtime of the whole system and try to start it with the minimum startup time. So for this, we try to use containerization to enable the seamless deployment and scaling. So as I said before, the containerization, which we try to basically use Docker, we also have different kinds of other tools, right? Like Podman, but we try to use Docker as it's the, let's just say, a standard industry standard for the containerization tool. So we try to use containerization to basically containerize the whole image. So container is not it's just a small VM or virtual machine that try to encapsulate all the only necessary runtimes and just remove all the unnecessary things to just minimize. So we just try to replicate the same environment in the development in different all the environments at the same time, so that the development and the production they might not be different and everything goes fine in all the environment. So yeah, for this we try to use containerization as I said before. So basically, if the docker build is good, then docker deploy will be good. And once we try to scale it, and the scaling is also very easier for us, and it should not provide us different kinds of errors while doing it. And yeah, it's all. So this possibility mainly basically tries to maximize the robustness with fast startup and graceful shutdown that Docker provides us by default. And we can also use a Docker Compose on top of Docker, which is, let's just say, a tool provided by Docker itself, to just start up a development environment via a single file, a YAML file, and you can just totally just recreate the environment that you needed for the development by a single command and stuff like that. So yeah, we try to just design apps that is disposable and easily replaceable. So on the next part, we have dev pro parity. So yeah, we try to in this. So in the typical software development environment, right? What we do in the organizations and what most of the organizations do is, so we try to replicate the different types of environment before going into the production. So currently in our organization, some projects have up to four environments on. So it can also have the two environments, only the staging and the production. It can also go from staging to UAT and production. Or sometimes in the bigger projects, it also goes from staging, let's just say from the dev, UAT, pre-prod, and production environment. So different kinds of testings might be being done on the environment before going to the production, right? So yeah, we try to. So in the factor number 10 in the depth broad parity feature of the feature of the 12 factor app methodology, we just try to maintain a similar environments among all of them, right? So let's just say from the CPU specifications to the containerization to app specification, everything and stuff like that. So we try to ensure consistency among environments to minimize issues. So for the building part, we try to create a build stage in different kinds of environments, right? So we try to set up a CI/CD for all our environments. So once it's done in one environment, we try to build it to another and another, so that the process is also fully automated. And let's just say the codes are also pretty much good, and it's good to go to the production, and let's just hope everything goes fine. So for this, so for this we try to mostly use the IAC tools, or let's just say the infrastructure as code tools that we have on our hand. So we have Terraform, and we have AWS or cloud specific tools like CloudForm 2, and we have some kind of other offerings from Azure, and we also have the same for let's just say from Google Cloud itself. And there are also new tools like Pulumi that tries to help you do the same from the native programming languages like TypeScript, Python. You can just create everything from scratch through it. So dev.parity is, let's just say, a factor that helps you to just similarize all the environments that you have without trying to break anything, so that everything goes into the production without any with lesser bugs, let's just say. So on the factor number 11, so we have logs. On this part of the 12 factor app methodology, we try to manage the logs. So we will be talking about logs. So what logs actually is. So if you are already developing Node.js applications or some kind of applications, you already get some kinds of logs, right? When you are development in your development phase. So we try to just maximize, or we try to manage the logs in the factor number 11 of this methodology. So we try to treat logs as event streams. So if, let's just say if we try to we have some kinds of logs that are being generated from the applications. We try to manage the logs as the event stream, right? So it should be real time and it should be coming, so that we can just analyze what is happening in that application. So occur, if we do not have logs, then it will be very, very hard for us to debug, right? So when the logs are there, we try to get the real-time log from it. Then let's just say it just makes our life easier for as a DevOps and as a developer. So for all of that, we try to just, if there are a lot of logs coming from an applications, since we are already trying to scale it out, there are different kinds of logs from different, if we are using Dockers and Kubernetes, from different types of containers and pods, right? So we just try to accumulate or all the logs coming from the application, let's just say be the backend or the front end or the database itself or the admin side, RabbitMQ, whatever there is, whatever the tools that are being used in the application, we try to monitor, we try to aggregate, monitor it, and just analyze it in the central log management system, right? So for this log management too, we have different kinds of offerings. We have paid offerings from Datadogs, we have New Relic, and we also have Splunk, or we can also use open source alternatives like ELK Stack, that is made up of three tools, or we can also use the let's just say newly being popular offerings from open source offerings from Grafana, Prometheus, and Loki. We can just use it to just centralize it and try to aggregate and analyze what the logs are being sent, and also the logs that are also generated from the system itself, the backend. So what where the applications are hosted from the Kubernetes itself, or let's just say the servers if you are using some kind of small servers on that. So yeah, everything should be treated as logs. So sorry, every log should be treated as event streams. So all the logs should be centralized in a certain kind of log management system, and so we should be using. So it should be a good practice, or let's just say it should be a must in DevOps world to be familiar with these kinds of log management systems as well. So yeah, on the factor number 12 of our uh, 12 factor app methodology, we will be talking about admin processes, right? So admin processes, it might be some kind of database migration or other kinds of stuff, right? That we might need to be doing while building a software. So it can be anything ranging from uh, database migration or some kind of other administrative tasks on the application. So what this factor or admin processes of the 12 factor app methodology and cloud native environment says is to run admin tasks as one of processes. So yeah, it's just trying to it just says to run it as one of processes. Also, it might be let's just say running different kinds of script to just back run into the table or connect it into other kinds of services and all the stuff like that. So we just try to do it with these tasks from some kinds of scripts to run it single way. So yeah, so everything is done in the single way. We try to automate it, and everything is tough on that. So yeah, I think we are on the end of the slide. So I have tried to explain you what I've learned from the DevOps and from what I am trying to use in the 12-factor tab methodology in my organization. So if there is any questions, please you are you are able to ask me the questions. So this is all from my end. So thank you everyone.
Thank you very much, sir, for your insightful presentation. It was incredibly informative and provided valuable insights. I would also like to request the audience to put up your questions in the chat box. At the end, we'll also address them. Um, Now, Mr. Ravi, I would like to ask you, what are some of the key changes you've observed in the industry over the years? You can also share a memorable project where your expertise in cloud-based architecture and automation made a significant impact.
Okay, that starting with a very tough question, I guess. In the recent trends, what I've seen is people are much more driven and interested in DevOps. They do not want just a developer who can do coding or development in one language, but people or companies, they really want full stack developers who can write their code, they can test it out, and they can actually put it into the production or live. So a single person can actually handle one project or one application from development to going live. So that is one of the changes I've seen. The second thing that I want to talk about is as we all, as we all know that IT is a game changer in what are the processes that are included in development, what are the processes that are experience. I think I've worked in a recent project where we were trying to do a serverless application. So we're using Firebase and GitHub Actions. So to just go with the, I will not go with the details, but uh, before 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 that process, we used to deploy the code in a server. We have to create a server, then install the dependencies, install everything that is required with databases or the web server, the application server, and we have to focus on that. So from development to production, it would take around, I guess, maybe 2 to 3 days live. But with the Firebase and GitHub process, GitHub action process, we're able to like deploy the code in like maybe 30 minutes scratch. So that was one of my achievements that I think I would like to talk.
Thank you, sir. Now, I think the next question I think aligns with the former part of your answer, but still, this was a question from one of our form responses. What things do you observe in an enthusiast so that you do not have to think twice about hiring them to make them work under your guidance? In DevOps, cybersecurity especially.
I have a personal bias. I don't think I'm the best person to answer that question. I don't look at people professionally. Like in an interview, I would not ask generally tech related questions or some loophole-ish kind of question where like I would ask how this is done, how that done. I would really one thing that I love about or want in a developer or an associate who work with me is the learning curve. That person can learn like easily on in anything, then that is the most important thing. If that person can learn, I would talk about something that that person has no experience in. I would give him or her some pointers, and then if they could pick on it, that is one of the qualities that I would. That is one of the qualities that I give preference to.
Thank you, sir. Now, can you please provide some examples of how different cloud platforms like AWS, Azure, Google Cloud, etc., have unique advantages or special cases, use cases?
Okay, uh, it's like AWS, Google Cloud, and Azure are pretty much similar. They have services, they have tools, they have all these parts that are pretty much equivalent to each other. They're very similar. The only thing that is different is their name. Like for AWS, a solution for storage is S3, and the same way Azure has what is it called?
Blob storage.
Blob storage. Yeah, blob storage. So the name is different, but what it does technically is pretty much same. With cloud services and IaaS like AWS and Google Cloud, they have provided so many services that someone who just knows how to code doesn't have to worry about anything except developing or writing the code. They can write it and testing, storing the code, then going it to deploying it to certain environments like development, production, staging. It will all be done by those services. You don't have to have expertise on how to do it. You don't have to know Linux, or you don't have to know how the server environments work. These IaaS like AWS would provide you with those services that would make it so easy for you to develop and uh, put the product live. That's the best quality in the sci-fi.
Now, Mr. Aman, could you please share some recent trends in cloud?
So if I have to say one of the most recent trends in cloud, then it would be the DevSecOps, right? So it's just the what we say, which it's just like aligning security with DevOps, right? So what it basically does is there's a term called shifting left. So what it does is before going to the production, everything the code is just statically analyzed for the security. So what might actually occur in the production for the security part. So it might be some kind of XSS scripting or some kind of SQL injections or some kind of API keys leakages inside the code itself. So one of the trends is that. So I would also say the serverless is also in the trend right now. So the secrets, it's also in the trend right now. Kubernetes. So basically, I would say the term DevOps itself is a trend right now in the market, mostly in Nepal, because most of the companies are actually trying to implement the DevOps currently, right? So before that, I would say there was not a lot of companies that were trying to do DevOps. So and now there's a lot of companies who are knowing about DevOps and trying to uh, implement it just to fasten their software development lifecycle and the software delivery process, I would say.
Sir, as you talked about CI/CD earlier,
Yeah.
can you share some best practices for implementing CI/CD pipelines in cloud native projects?
So if I have to say one of the best practices, then it would be to make a CI/CD pipeline. It should be dynamic, right? So a same CI/CD pipeline. In my case, if I would have to see it in GitHub Actions. So the same GitHub Action should be able to deploy it seamlessly into the let's just say into the staging environment, into the UAT environment, or the production environment from the same CI/CD pipeline. So what it basically should do is try to differentiate the environment by some kind of tags. In our term, let's just say brands. So it should be able to detect the certain secrets by brands, and it should be able to deploy it seamlessly. And if I would say, then I would say that the yeah, I would say that would be the best, one of the best practices for CI/CD. The CI/CD should be dynamic for all the environments with the same file.
Yes.
Now,
Can I
yes.
can I add something to that? Yes. So one point I'd like to add with Aman's point is a pipeline should be able to deploy to all the environments. At the same time, one of the features that I would like to add is segregation of secrets, or rather than implementing the secret in your code. Uh, for example, there's an API key or a database point or some other secret. Then rather than hard coding it into an environment file, uh, we the best practice would be to put it into a secret or some kind of a mechanism where it is loaded into the server during the build process, not before it, so that your secrets are not exposed anywhere.
Sir, now I think this is a very common question. How does cloud native development differ from traditional software development?
Okay. Mm, should I answer or Aman should answer?
Anyone can.
Okay, so I think uh, in 2023, can you please what was the difference between cloud native and the other one? What was the other one?
And traditional software development.
Traditional software. So in 2023, I think every traditional software development is cloud based. It is not traditional as traditional, because if we go back like a decade or so, we would have to create servers in our offices or in our organizations for that applications to work. There were not internet infrastructures. We would have to wait long for our code to be pushed, or our, let me give an example. A traditional in a traditional development that I've worked at, we used FileZilla. So one of the developers would code a change in the code, and then we would zip it, and then we'd use FileZilla to put that code into the server. That would like take on 30 minutes or so, and then we'd go and do it manually, zip it, put the changes there, make any other changes to the server, maybe configuration changes, and then the server would go live. But now I think that is pretty much dead, because no one is hosting these servers here. I mean, they are, but very least. And because of the cost availability and internet availability, since internet is easily available, the speeds that we work with is high enough for us to uh, connect in the server in the US or Australia and just do it easily and in short time, as well as the cost reduction of cloud based. If we were to serve, we were to create a server in our office in Kathmandu, it would cost more than a simple server in AWS. Like an AWS server would cost us around maybe $10 per month. Uh, if we take that in account, our server, the initial up cost would be high, and keeping it maintained, that would cost us. So cost and the availability of internet pretty much makes cloud development or cloud native applications the choice, uh, just killing the traditional development.
Now, sir, what are the common challenges that the organizations face when transitioning to cloud native development, and how do they overcome them?
Uh, I think the biggest challenge would be the false sense of security. People would find it uh, that their application, that their product is secure if it is hosted in their own home or own office. That is much more secure. But the internet doesn't work like that. If your server has access to internet, anyone can access your server or your code or your application. So it doesn't work like that. You have to first overcome that barrier, that cloud is as secure as your servers. That's one of the thing. And the second thing would be, if you are hosting or if you're using your local service for your applications, then you'd not be able to uh, uh, CDN, so cloud delivery network. It's a technology where your assets or your files are distributed throughout the world. If I have a file, if I have an image file, then if I put it in a server in my location, someone accessing it from US would have very high latency, and they would not be able to download it or access it extremely fast. But with CDN, those files are copied throughout the world in servers that is available, right? With that, there would be the download time or the load time of the application would reduce drastically. So if you want to make your app secure and if you want to make your app faster, you would want to go with cloud native applications.
So we must focus on scalability and security.
Yes. Yes, that as well. I've missed that point.
Now, yeah, we have one of the questions from form responses regarding team collaboration and development workflows. How does embracing the 12-factor app methodology impact the way developers work together and manage projects?
Uh, it is not a hard and fast rule, the 12 methodology. It's a methodology that we found that most of the factors mentioned there, we have been implementing it, we have been using it. So with the use of it, you'd be able to easily develop codes and go to prod. And for collaboration, as we have talked about, these tools like GitHub and other tools, that makes it easier, right? So yeah, I actually forgot your question. Can you please repeat your question?
Regarding team collaboration and development workflows, how does embracing the 12-factor app methodology impact the way developers work together and manage projects?
Yes. So each factor mentioned there does one one thing or another. Like with the code base, you'd be able to collaborate easily. Your changes, like if one application is being developed by, let's say, 50 developers, all these changes have to be synced into one code base, right? So GitHub would provide, or GitLab, or any BBS, sorry, Git provider would provide that solution. Uh, Similarly, a factor called the Dev pod parity. With that, you could make changes to your Dev environment and see if that breaks or not. So without affecting production, we could do many changes in that Dev environment or staging environment. And after testing it thoroughly, we could make that change available on the live product. So similarly, if I keep explaining all the factors, that will take a long time. But each factor helps in one way or another. But you have to make sure that everybody understands how this works and how the flow or the processes are to be done.
So I think we're done with our questions. If anyone from the audience has any question, then you can put up in the chat box. So till then, can you do you have any suggestions for the students like us who are exploring in different fields, or were enthusiastic about DevOps and its fields? Like, do you have any suggestions for them?
Yeah, eh, let's just say if you are a developer or an aspiring developer, then it's like uh, if you learn the DevOps principle, if you learn the DevOps methodologies, then it will be like a cherry on cake. You are already a cake. You know how to develop, but if you know how to uh, make your application go live without anyone's help, then you would be preferable to any other developer who's holded by a language or some kind of technique or technology that he expertises on. But with DevOps, you have that upper hand in companies, and as yourself, let's just say if you're not even working in a company and if you want to develop your own code, then you do not need anyone's help. You just want to know the part where how to code it and what you want from their application, and then you'd be able to go from your computer to a live where your product can be used by everyone, right?
Thank you, sir. Mr. Aman, would you like to say something on it?
Yeah, if I have to say something, then let's just say that try exploring a lot of things, right? You can go starting from front end to back end. Just not stick to some kind of framework. So you should, I think, as a developer, you should be able to know how a system works too, because I think a developer should not be only attached only to his IDE, right? So he should be able to explore the system, how everything works into going into the production, how the production work. Let's just say they should have some kind of knowledge on that. So I would say just to start young, try exploring, try testing. You have all the internet knowledge available to you. Just Google something out, just run everything through Google, just go through the GitHub, go through the open source projects, because you can learn a lot from open source projects, right? So just try to see what the project is about. If you find learn it, you should be able to find something out of it. Yeah, I would say that just start young and try to be busy. Just try to get on the trends with all what it is happening. Just try to know what it is offering, because it world is continuously revolutionizing and just giving different kinds of things to us, right? So yeah, just try to stick with the trends, try to follow the blogs, try to just listen to some kinds of podcast, try to look into the documentations, do everything, try to do some projects, just not look into the theories part of the application, and try to just build something. I would say build and break something. Thank you. Yeah, I would say this much. Thank you.
Thank you, sir. We have a question. There's a controversial saying that DevOps shouldn't be a separate job. Instead, a dev should learn DevOps themselves as instead, a developer should learn DevOps themselves, as it's a basic knowledge every developer should have. What's your say on this statement?
I agree. I should leave my title and just stay at home as well. So I agree with that. I agree with that. Yes. In Nepal, especially, we are highly like attached to titles, but there should not be a DevOps engineer. It's something. It's a knowledge, or it's a principle that you know about or work with. It's not something like I'm a front end developer, I'm a back end developer. That's something technical, but DevOps is not like that. It's much more of a principle, you know. It's about breaking those silos. Like there's a development team. There is a production. Sorry, there's a operations team. So it shouldn't be like that. There should be a project, and in that project, let's say there are five people, then everyone should be able to do it, or know the aspect of the application on how it works and how it can be brought to the servers or live. I do agree with that.
So I think we have another question. How to run GUI application directly on Docker, not port forwarding, but to have direct GUI access on Docker.
This is pretty much a technical question. I could be a bit rude and say like you should Google this and end this, but my suggestion to this question is Docker is specifically not made for GUIs or uh, let's say accessing it through your computer. For example, we do what is it that we do like with TeamViewer? What is it called? Forgot the term.
RDP. RDP.
Yeah, RDP, like RTP. That's a protocol, but what is it?
Remote sharing, they.
Remote sharing. Yeah, remote sharing. So Docker is not meant to be used for these processes. Like, yes, this can be done, but you should not do it for this, you know, because Dockers are generally meant for microservices that are to communicate with each other rather than using this. So there is specifically, I think, I would put out a link on how to do this later on if this person who had asked this is really interested in. Uh, can we do that?
Sure, sure.
Uh,
Sure. Now, can you shed some light on how is the industry like, the tech industry, the DevOps industry?
it is very cruel and brutal. Yes. So it's just my perspective. It's my opinion. But I think like the question you asked earlier, like it should not be a job title, right? So it should not be a job title. But still, we are working as DevOps engineers because we are still trying to make that aspect clear to all the developers, you know, the people like in our company or in our organization or other organizations that we work with, people are pretty much interested in development. They want to know one language and they would like to work on it and they want to be expert on it, you know. They would start at as associate JavaScript developer, then they would become JavaScript developer, then senior JavaScript developer, and then JavaScript lead and something like that. So they want to go on that vertical path. But to be a full stack developer, I think you have to know the principle of DevOps and actually implement it in your development cycle. Right? That's what I think. One of the things that I am dissatisfied is people do not want to be DevOps engineer because they think that there is no market for it, or like if I get hired as a DevOps engineer in one company, I would not have the opportunity. If I move on from that company to another company, then I would not have the opportunity. As the job for developers are pretty much highly available, the same cannot be said for DevOps uh, uh, engineers or DevOps as a job, right? So I think it is a misconception, because if you already know how to develop and then you have the insight on how to operate your application, I think every company would love to have you in their team.
So it's not about the limited seats, it's about the limited participants.
Yes, I guess.
Okay. Um, okay, I think we're done with our question. Now I would like to ask Mr. Mohipadikari, the KU HackFest 2023 lead, to take over the platform and conclude the session. Yeah. Thank you, sir.
Sure.
Bismillah,
Thank you.
thank you so much. Thank you, Ravi sir and Aman sir, for your insightful talk. We are very grateful to have you on our talk. So, also thank you at this team, and thank you, Srila, for hosting the show and making the talk so very effective. The talk show is pre-event of KU HackFest 2023. KU HackFest 2023 is pre-event of IT Meet 2023, which is the annual event. Also, KU HackFest is co-powered by Asterdio INC, and our guest Ravi sir and Aman sir are from Asterdio INC, which is a company located at Sanghamul. So thank you Asterdio for sponsoring us as our co-sponsor. Also, I want to provide our guest Aman sir and Ravi sir with a virtual token of love. And I also want to invite both of you on our Hackfest, which is going to be held from 29 September to October 1. So thank you so much. Deepen, will you please share the token of love, the virtual token of love?
I would like to say some last words, I guess. Thank you, Mahiji, and thank you, Shilaji, and all the organizers here for hosting us. And I would like to say that all the best to all the participants, and I hope you can implement some of the ideas that we have pitched today and use it in your project that you're going to do in your Hackfest.
Thank you, sir. Thank you so much. Also, we would love to have you both on Hackfest as a mentor to mentor to the participant, as you both are one of the greatest from our industry, from the industries. So I would also like to invite both of you in the event. So Dipen, will you please share the token of love?
स्क्रिन सेयर भइरहेको छैन हो
Voice.
Sorry.
Internet slow वाला.
Sorry, screen to share भएको छैन.
नेपालीमै कुरा गर्नुपर्ने रहेछ यार. लास्ट टाइममा त नेपाली.
पहिला चाहिँ के हुन्थ्यो भन्दाखेरि हाम्रो सिन्स पहिला चाहिँ भर्चुअल हुन्थ्यो हाम्रो ह्याकाथन.
Okay, thank you guys.
These are the virtual, since हाम्रो चाहिँ अब भर्चुअल भयो टक सो, सो दिस इज द भर्चुअल टोकन अफ लभ. तपाईँहरू जब केही एक्सेसमा हुनुहुन्छ, we will provide you the physical token of love.
Okay. So I have to be there to get the
Okay.
token of love, I guess.
Yes.
के जानु पर्यो त अब
Yes.
के राम्रो छ नि. So I guess this is it. I guess we have to end the talk so. हजुरहरूले लास्टमा केही भन्नु छ कसैलाई? रवि सरले भन्नुभयो, अमन सरलाई केही भन्नु छ भने?
आई जस्ट वान्ट टु से गुड लक टु सबैजनालाई अब राम्रो गर्नु अब त्यही हामीले अब केही टुल्सको बारेमा त भनेको छौँ अब त्यस्तो प्र्याक्टिकली त गएको छैनौँ सो लेट जस्ट ट्राई टु इम्प्लिमेन्ट लेट जस्ट राम्ररी गर्नु गो थ्रु द डकुमेन्टेसन्स एन्ड एभ्रिथिङ गो टु द ब्लग्स त्यही हो सबैभन्दा सबैजना राम्रो गर्नु मे द बेस्ट वान विन्स गुड लक एभ्री वान थ्याङ्क यू होप यो सिजन चाहिँ राम्रो भयो होला तपाईँहरू सबैजनालाई थ्याङ्क यू थ्याङ्क यू टु अर्गनाइजेसन्स सबैजना
धन्यवाद, धेरै धेरै धन्यवाद. थ्याङ्क यू बोथ अफ यु टु. अल्सो मलाई चाहिँ हजुरको मेल गरिदिन मिल्छ?
हुन्छ, स्योर.
हुन्छ
मेल गरिदिनु
केमा
है.
गरिदिनु तपाईँलाई
म यहाँनिर हाम्रो डाइरेक्ट यता एभ्री वान नभएर सिङ्गल मलाई नै पठाउनु मिल्छ होला.
हुन्छ पक्नै त म एकचोटि हेरेर पठाइदिन्छु तपाईँलाई